Okay, for this problem, we're also going to have to start out with a balanced equation. So that's going to look like this. Iron chloride plus silver nitrate produces iron 2 nitrate and silver chloride. And these abbreviations here stand for solid, aqueous, and aqueous just means dissolved in water, so you don't need to worry about putting those equations in your balanced equation. Okay, I'm going to go ahead and balance the equation and write in the molar masses now. Okay, those are the molar masses and the balanced equation. If you have trouble doing either of those things, balancing an equation or calculating molar masses, please, please, please see me so that I can help you. Okay, so now this one tells us that we have 6.28 grams of iron 2 chloride and it's mixed with excess silver nitrate. So anytime it tells you which one's excess, that actually makes the problem easier because that's telling you you're only going to need to do one picket fence. So it says that the silver nitrate is excess, which means that the iron 2 chloride is the limiting reactant, and so the limiting one is the one that we need to do calculations with. For this problem, we're going to end up using the equation for percent yield. This is on your periodic table, but also I'm going to give it to you right now. The percent yield is the actual yield divided by the theoretical yield times 100. And the actual yield is often given to you in the problem. Like in this case, it says the reaction yields 7.75 grams. That's going to be the actual yield. The theoretical yield is usually what you're going to do a calculation to find. So we're about to do a calculation that's going to give us the theoretical yield of iron 2 nitrate. So it says, what is the theoretical yield of iron 2 nitrate? We're starting at iron chloride. We need to convert from grams of iron chloride to grams of iron 2 nitrate. So from here to here. So we have grams here. We need to put grams down here. We will use the grams for iron 2 chloride, which is 126.75. And that is a molar mass, so that equals 1 mole of iron chloride. Now we want to get from iron 2 chloride to iron nitrate, so we are going to use the mole ratio. So we have 1 mole here and 1 mole here, so both of these are going to be 1 mole. And then we are going to need to go to grams of iron 2 nitrate. So molar mass is always equal to 1 mole. And the molar mass in this case is 179.87 grams. So when we type all of that in, we get 8.91 grams of iron 2 nitrate. That is our theoretical yield. So to find the percent yield, we're going to put where the theoretical yield goes, we're going to put the 8.91. Where the actual yield goes, we're going to put the actual yield that's given in the problem, and then we're going to multiply by 100, and when you type that all in, you get 87.0% yield. So we would put in for our theoretical yield this number, 8.91, and then in for our percent yield, we would put 87.0. Okay, this problem, I honestly put this on your OWL assignment because it is easy and can get you some points in case you have trouble doing the other problems, but it also is a really good reminder of how we convert. So if we want grams of BaCl2 to get to moles of K2SO4, first we have to get from grams to moles, and then we have to get from moles of one thing to the other. So now notice that this equation is already balanced. It has a coefficient of 2 here. If it wasn't balanced, we would have to balance it, but it's already balanced. So we have grams of BaCl2 here. So down here we have to have grams. And on the OWL program, you don't have to put in the BaCl2. You can, but you don't have to. And then here, we need the number. So you're going to add up the molar mass of barium chloride. Barium's mass is 137.33, and there's 2 chlorines, and chlorine's mass is 35.45. When we type that in, we get 208.23 grams per mole. So here we're going to put 208.23 grams per 1 mole. Now that would get us to moles of barium chloride, but we want moles of potassium sulfate. So we need to look and see how many moles are in the balanced equation for each of these. It happens to be 1 to 1. So we're going to say 1 mole of barium chloride is equal to 1 mole of potassium sulfate, and then we would be done with the problem and you could hit submit. Now, if there was numbers here, if there was a 2 or a 3 or a 4 here, you'd have to put numbers in instead of ones, but in this case, since they're blanks, you just put in ones. All right, so this one we need to start with a balanced equation. We have iron, solid, so it can be by itself, plus oxygen. Now, oxygen is in Hofbrinkel, and anything that's in Hofbrinkel, we have to give a subscript of 2. Produces iron 3, and oxygen is a -2 charge, so we switch those and we get Fe2O3. And then to balance this, we need to get the oxygen to 6 because there's 2 here and 3 here, so we put a 2 there and a 3 there, which gets both of our oxygens to 6. And then we have 4 irons over here, so we have to put a 4 here. So there's a balanced equation. The problem says how many moles of iron 3 oxide. So we want to find out how many moles of iron 3 oxide we have will be formed upon the complete reaction of 24.4 grams of iron with excess oxygen gas. So again, this excess is just telling us that iron is the limiting reactant and we only need to do 1 picket fence. So 24.4 grams of iron, we want to get that to moles of iron 3 oxide. So we have grams here, so we have to put grams down here, and we look up the molar mass of iron on the periodic table and find that it's 55.85 grams of iron is equal to 1 mole of iron. And then now we do a mole ratio. So we have moles of iron, which cancels here, and there are 4, so we put a 4 down here. We want to get to moles of iron 3 oxide, so we put 2 moles of Fe2O3 up here. And because we're looking for moles of iron 3 oxide, we are done. We type that in, and we get 0.218 moles of Fe2O3